Ever wondered why your high-performance Java application suddenly hangs or produces inconsistent results under heavy load? Most of the time, the culprit is a subtle concurrency bug. In this video, we will cover Java Multithreading and Concurrency Masterclass, practice questions and detailed explanations. Master Java Multithreading and Concurrency with this comprehensive practice guide. In this video, we are diving deep into 30 high-yield practice questions designed to help you master Java multithreading and concurrency. We'll cover everything from thread lifecycles to the complex Java memory model and the latest concurrency utilities. Before we begin, make sure to grab a notepad. I'll be explaining the why behind every answer so you can apply these concepts in real-world scenarios. Which method must be implemented by a class that implements the runnable interface? Option A, public void start. Option B, public void run. Option C, public void execute. Option D, public void init. The correct answer is B. The runnable interface is a functional interface in Java that contains a single abstract method. Public void run. Single quote. When a thread is started using a runnable object, the JVM calls this run method in a separate execution context. Unlike the start method, which is found in the thread class and is used to allocate resources and initiate a new thread. Run defines the task itself. If you call run directly instead of start, the code executes on the current calling thread rather than a new one. What is the primary purpose of the volatile keyword in Java? Option A, to ensure that a block of code is executed by only one thread at a time. Option B, to prevent a variable from being cached in a thread's local memory. Option C, to create an atomic operation for compound statements like I++. Option D, to allow a thread to go into a waiting state. The correct answer is B. The volatile keyword addresses visibility issues in a multi-threaded environment. In modern CPUs, threads may keep a local copy of variables in registers or cache for performance. This can lead to situations where one thread updates a variable, but others don't see the change. Marking a variable as volatile forces the JVM to always read from and write to the main memory. However, it is important to note that volatile does not guarantee atomicity for compound operations. Like increments, it only guarantees visibility and prevents instruction reordering by the compiler. In the context of concurrency, what is livelock? Option A, a situation where two threads are blocked forever, waiting for each other. Option B, a state where a thread is waiting for a resource that is never released. Option C, a situation where threads constantly change their state in response to each other without making progress. Option D, when a thread consumes all CPU cycles in an infinite loop. The correct answer is C. Livelock is similar to deadlock in that no progress is made, but the threads are not technically blocked. Instead, they are active and responding to one another. A classic analogy is two people meeting in a narrow hallway. Both move aside to let the other pass, but they keep moving to the same side simultaneously, never actually passing each other. In Java, this often happens when retry logic is poorly implemented, causing threads to keep backing off and retrying in a synchronized loop that never completes. Which of the following classes is best suited for a scenario where you need to wait for a specific number of events to complete before proceeding? Option A, semaphore. Option B, cyclic barrier. Option C, countdown latch. Option D, exchanger. The correct answer is C. Countdown latch is a synchronization aid that allows one or more threads to wait until a set of operations being performed in other threads completes. It is initialized with a given count. The await method blocks until the current count reaches 0 due to calls to the countdown method. Unlike a cyclic barrier, a countdown latch cannot be reset once the count reaches 0, making it ideal for one-shot events like starting a service only after all its dependencies are initialized. Which of these is not a guarantee provided by the happens before relationship in the Java memory model? Option A. An unlock on a monitor happens before every subsequent lock on that same monitor. Option B. A write to a volatile field happens before every subsequent read of that same field. Option C. A call to thread start happens before any action in the started thread. Option D. All threads will see the same order of execution for non-volatile variables across different CPU cores. The correct answer is D. The Java Memory Model, JMM, does not guarantee that all threads see the same order of execution for non-volatile variables. This is due to compiler optimizations and CPU instruction reordering. The happens before rule defines specific conditions, like monitor locks, volatile variables, and thread starts, under which the memory writes of one statement are guaranteed to be visible to another statement. Without these specific synchronization points, the JVM is free to reorder operations for performance, which can lead to data races. What is the result of calling thread stop in modern Java versions? Option A. It safely terminates the thread and releases all locks. Option B. It is deprecated and considered inherently unsafe because it releases all locked monitors immediately. Option C. It is the recommended way to end a background task. Option D. It puts the thread into a blocked state. The correct answer is B. The thread stop method has been deprecated since Java 1.2 because it is inherently unsafe. When a thread is stopped forcibly, it unlocks all the monitors it has locked. If any of the objects protected by these monitors were in an inconsistent state, other threads may now view these objects in that corrupted state. This can lead to unpredictable behavior that is extremely difficult to debug. The correct way to stop a thread is by using an interrupt mechanism or a shared volatile Boolean flag. How does reentrant lock differ from the synchronized keyword? Option A. Reentrant lock does not support reentrancy. Option B. Reentrant lock allows for a fairness policy and attempt to acquire lock with timeouts. Option C. Reentrant lock is automatically released at the end of a block. Option D. Synchronized is much faster than reentrant lock in Java 21. The correct answer is B. While both provide mutual exclusion, reentrant lock offers extended capabilities that the synchronized keyword does not. These include the ability to specify a fairness policy, giving the lock to the longest waiting thread, the try lock method, which allows a thread to back off if the lock isn't available immediately, and the ability to be interrupted while waiting for a lock. However, reentrant lock requires explicit unlocking in a finally block, whereas synchronized blocks are automatically managed by the JVM. Which collection should be used when multiple threads are reading frequently but writing rarely? Option A. Collections. Synchronized list. Option B. Concurrent hash map. Option C. Copy on write array list. Option D. Vector. The correct answer is C. Copy on write array list is designed for scenarios where traversal, reading, vastly outnumbers mutations. Writing. For every write operation, add, set, remove, it creates a fresh copy of the underlying array. This means that iterators will never throw a concurrent modification exception and do not require separate synchronization during traversal. However, because of the array copying, write operations are very expensive, making it unsuitable for high-frequency update scenarios. What happens when you submit a task to a thread pool executor that has reached its maximum pool size and its queue capacity? Option A. The task is silently discarded. Option B. The thread pool expands beyond the maximum size. Option C. The rejected execution handler is invoked. Option D. The calling thread is automatically blocked until space becomes available. The correct answer is C. When a thread pool executor cannot accept a new task, because all threads are busy and the work queue is full, it consults its rejected execution handler. By default, the abort policy is used, which throws a rejected execution exception. Other policies include caller runs policy. The thread that submitted the task executes it itself. Discard policy. Silently drops the task. And discard oldest policy. Drops the oldest unhandled request and retries. Which mechanism do classes in the Java Util concurrent atomic package primarily use to achieve thread safety? Option A. Strict synchronization. Option B. Compare and swap. CAS. Option C. Spin locks. Option D. Thread local storage. The correct answer is B. Atomic classes like atomic integer use a low-level CPU instruction called compare and swap. CAS. CAS is an optimistic locking technique. It compares the current value of a variable to an expected value. If they match, it updates the variable to a new value in a single atomic step. This is much more efficient than traditional locking because it avoids the overhead of thread context switching and kernel-level arbitration when contention is low. What is the difference between execute and submit methods in ExecutorService? Option A. Execute is for runnable. Submit can take both runnable and callable. Option B. Submit returns a future object. Execute returns void. Option C. Execute throws checked exceptions. Submit does not. Option D. Both A and B are correct. The correct answer is D. The execute method is defined in the executor interface and takes a runnable, returning nothing, void. It is a fire and forget approach. The submit method, defined in the ExecutorService subinterface, is more versatile. It returns a future object that can be used to check if the task is finished, wait for its completion, and retrieve the result, if using callable. Furthermore, if a task submitted via submit throws an exception, it is caught by the future and only thrown when you call future.get. Which of the following describes a daemon thread? Option A. A thread that prevents the JVM from exiting. Option B. A high-priority thread used for GUI rendering. Option C. A low-priority service thread that does not prevent the JVM from exiting. Option D. A thread that runs in a separate process. The correct answer is C. In Java, threads are either user threads or daemon threads. The JVM will continue to run as long as there is at least one user thread alive. Daemon threads are background providers of services, like the garbage collector. Once all user threads have finished, the JVM will abruptly terminate all daemon threads and exit. You can mark a thread as a daemon by calling setDaemon true before the thread is started. If a thread calls a synchronized instance method, which lock does it acquire? Option A. A lock on the class object. Option B. A lock on the this object instance. Option C. A global JVM lock. Option D. No lock is acquired. Synchronized only prevents reordering. The correct answer is B. When a non-static method is marked as synchronized, the thread must acquire the intrinsic lock monitor for that specific instance. This before it can execute the method body. If another thread wants to execute any synchronized instance method on that same object, it must wait. However, it can still execute non-synchronized methods or synchronized methods on a different instance of the same class. What is thread starvation? Option A. When a thread is waiting for a lock held by a deadlocked thread. Option B. When a thread is unable to gain regular access to shared resources and is unable to make progress. Option C. When the CPU is too busy to schedule any threads. Option D. When a thread crashes due to an out-of-memory error. The correct answer is B. Starvation occurs when a thread is perpetually denied the resources it needs to make progress. This often happens if greedy, high-priority threads consume all the CPU time or if a synchronization policy, like a non-fair lock, consistently favors other threads. For example, if a thread pool is too small and long-running tasks occupy all threads, new tasks will starve in the queue. What is the primary design pattern used by the fork join pool? Option A. Producer-consumer. Option B. Work stealing. Option C. Observer pattern. Option D. Singleton pattern. The correct answer is B. The fork join pool uses a work stealing algorithm. Each worker thread in the pool has its own double-ended queue deck of tasks. When a worker thread finishes its tasks, it looks at the queues of other workers and steals tasks from the back of their decks. This ensures that all threads remain busy as long as there is work to be done, maximizing CPU throughput for recursive divide and conquer tasks. Which of the following is true about concurrent hash map in Java 8 and later? Option A. It locks the entire map for every write operation. Option B. It uses a single lock for both reads and writes. Option C. It uses a striping or bucket level locking mechanism to allow concurrent updates. Option D. It is not thread safe and requires external synchronization. The correct answer is C. Concurrent hash map is designed for high concurrency. Instead of locking the whole table, it uses a finer-grained locking strategy. In Java 8+, it typically locks only the head of the specific bucket node being modified. Multiple threads can update different buckets simultaneously without interfering with each other. Read operations are generally non-blocking and do not require locks. providing high performance for read-heavy workloads. Which method in completable future is used to combine two independent futures and perform an action? When both are complete, option A, then apply. Option B, the end compose. Option C, then combine. Option D, apply to either. The correct answer is C. Then combine is used when you have two independent completable futures and you want to execute a function when both are finished. The function takes the results of both futures as arguments. In contrast, the end compose is used to chain futures where the second future depends on the result of the first, flattening a nested future. What is the main difference between cyclic barrier and countdown latch? Option A. Cyclic barrier can be reused after the waiting threads are released. Countdown latch cannot. Option B. Countdown latch can be reused. Cyclic barrier cannot. Option C. Cyclic barrier is for single threads only. Option D. There is no functional difference. The correct answer is A. A cyclic barrier is cyclic because it can be reused after the waiting threads are released, making it useful in iterative algorithms where a set of threads must wait for each other at the end of every phase. A countdown latch, however, is a one-use barrier. Once the count reaches 0, the latch is open forever and cannot be reset. Which statement regarding thread local variables is correct? Option A. They are shared across all threads in the JVM. Option B. They provide a separate copy of a variable for each thread. Option C. They are automatically synchronized by the JVM. Option D. They can only store primitive data types. The correct answer is B. Thread local provides thread local variables. Each thread that accesses such a variable via its get or set method has its own independently initialized copy of the variable. Thread local instances are typically private static fields in classes that wish to associate state with a thread, e.g., a user ID or a transaction ID. It is a way to achieve thread safety without using synchronization. What is the behavior of the wait method? Option A. It pauses the thread for a specified time without releasing locks. Option B. It causes the current thread to wait until another thread invokes notify or notify all for this object while releasing the lock. Option C. It is a static method in the thread class. Option D. It can be called from any method regardless of synchronization. The correct answer is B. The wait method belongs to the object class. A thread must own the object's monitor, be inside a synchronized block method to call wait. When wait is called, the thread releases the lock and enters the waiting state. It will only wake up if another thread calls notify or notify all on the same object, after which it must reacquire the lock before continuing. What is the state of a thread that has been created but not yet started? Option A, runnable. Option B, waiting. Option C, new. Option D, blocked. The correct answer is C. A thread is in the new state when an instance of the thread class has been created but the start method has not yet been invoked. Once start is called, the thread moves to the runnable state. It cannot return to the new state once it has started. What is a stamped lock in Java 8? Option A, a lock that requires a digital signature. Option B, a capability-based lock that provides 3 modes: writing, reading, and optimistic reading. Option C, a replacement for the synchronized keyword that is deprecated in Java 17. Option D, a lock used specifically for logging purposes. The correct answer is B. Stamp lock is an advanced lock introduced in Java 8 that can be faster than reentrant read-write lock. It provides optimistic reads where you can read without acquiring a full lock. You then validate a stamp to see if a write occurred during your read. If it did, you then fall back to a heavy read lock. This significantly improves performance in high read, low write scenarios. Which method is used to gracefully shut down an executor service? Allowing previously submitted tasks to execute? Option A, stop now. Option B, shut down. Option C, shut down now. Option D, terminate. The correct answer is B. The shutdown method initiates an orderly shutdown in which previously submitted tasks are executed, but no new tasks will be accepted. In contrast, shutdown now attempts to stop all actively executing tasks, halts the processing of waiting tasks, and returns a list of the tasks that were awaiting execution. Which of these is a valid way to prevent a race condition? Option A, using volatile for all shared variables. Option B, ensuring all shared data is accessed within synchronized blocks or using atomic variables. Option C, increasing the CPU priority of the threads. Option D, using a thread sleep call between operations. The correct answer is B. A race condition occurs when the outcome of a program depends on the non-deterministic timing, interleaving of threads. To prevent it, you must ensure mutual exclusion. Only one thread accesses the data at a time. Or atomicity. Synchronized blocks and atomic classes provide these guarantees. Volatile alone is insufficient for compound operations, like check then act, and thread sleep only makes the race condition harder to trigger. It doesn't eliminate it. What is the purpose of a semaphore in Java? Option A, to ensure only one thread can ever run. Option B, to control access to a shared resource by maintaining a set of permits. Option C, to exchange data between two threads at a rendezvous point. Option D, to signal the JVM that a thread should be garbage collected. The correct answer is B. A semaphore maintains a set of permits. Each acquire blocks if necessary until a permit is available, and then takes it. Each release adds a permit, potentially releasing a blocking acquirer. Semaphores are often used to restrict the number of threads that can access some physical or logical resource, such as a database connection pool. What is instruction reordering? Option A, the JVM changing the order of lines in your source code. Option B, the compiler or CPU changing the execution order of statements to optimize performance. Option C, the user manually changing the priority of threads. Option D, a runtime error when instructions are missing. The correct answer is B. Instruction reordering is a performance optimization performed by the compiler, the JVM, and the hardware, as long as the result in a single-threaded context is the same. The system may execute statements in a different order than written. However, in multi-threaded programs, This can lead to broken logic if proper synchronization, like volatile or synchronized, is not used to establish visibility boundaries. Which of these is a thread-safe implementation of a queue that blocks when trying to take from an empty queue? Option A, linked list. Option B, priority queue. Option C, link blocking queue. Option D, array deck. The correct answer is C. Link blocking queue is a thread-safe implementation of the blocking queue interface. It is blocking because its take method will wait for the queue to become non-empty, and its put method will wait for space to become available. If it's a bounded queue, this makes it ideal for producer-consumer patterns. What happens when a thread's run method completes? Option A, the thread goes back to the new state. Option B, the thread enters the terminated state. Option C, the thread is automatically restarted. Option D, the thread stays in the runnable state indefinitely. The correct answer is B. Once a thread's run method finishes, either by returning normally or by throwing an unhandled exception, the thread enters the terminated state. Once a thread is terminated, it cannot be restarted. All resources associated with the thread are eventually reclaimed by the JVM. What is a deadlock? Option A, when a thread is waiting for input from a user. Option B, a condition where two or more threads are blocked forever, each waiting for a lock held by the other. Option C, when a thread throws a runtime exception. Option D, when the JVM runs out of memory. The correct answer is B. Deadlock occurs in a multi-threaded environment when two or more threads are blocked forever, waiting for each other. For example, thread A holds lock 1 and waits for lock 2. Simultaneously, thread B holds lock 2 and waits for lock 1. Neither can proceed, and they will stay blocked until the program is terminated. Avoiding nested locks and acquiring locks in a consistent global order are common ways to prevent deadlock. What is the result of calling future.get? Option A, it returns the result immediately, or null if not ready. Option B, it blocks the calling thread until the computation is complete and then returns the result. Option C, it cancels the task. Option D, it returns a boolean indicating if the task is done. The correct answer is B. The get method of a future is a blocking call. When you call it, the current thread will be put in a waiting state, until the background task finishes its execution and returns a value. If the task is already finished, it returns the result immediately. You can also use a timed get, long timeout, time unit, to avoid waiting indefinitely. That wraps up our 30 practice questions on Java multithreading and concurrency. How many did you get right? Let me know in the comments below. If you found this video helpful, please give it a thumbs up and subscribe for more deep dive Java content. If you want to test your skills with a full-length timed exam, check the link in the description for our comprehensive practice test suite.